Average rate of change. Finding the average rate of change is like when you're traveling from one town to the next, you're going to be traveling at different speeds at different times. You have to come to a stop sometimes. There are other times where the speed limit is lower, other times the speed limit is higher. But you can figure out on average what your speed was during the time you traveled from point A to point B. Or maybe you have a business and sometimes it's making money, sometimes it's losing money, but maybe overall, over the course of a year, it averaged making money. And so those types of examples are examples of average rates of change. It doesn't tell you what the rate was at any exact moment, just over a period of time, on average, how things were changing. And a way to write a formula for the average rate of change is in function form, which is like this: f of b minus f of a all over b minus a. So if you remember, when things are written in function form, the numbers inside the parentheses are the x's. So that means the b and the a are actually x's. And then once they're plugged into the function and worked out, those values are the y values. So we've got two different y's and two different x's. Let's call the top first y2 minus y1, and then on the bottom x2 minus x1. So hopefully that formula is familiar to you as the slope formula. So slope is an average rate of change. And so this is going to provide a little bridge to calculus for us. Calculus deals with instantaneous rate of change. So this is a way to kind of get you thinking about slope as something different besides just how steep a line is. It also tells you on average how fast something is changing. Now suppose we want to find the average rate of change of this function between the 2 points that are plotted, and a dotted line has been drawn to show that we're trying to find the average rate of change between the point 0, 6 here at the top and the point 5, 2. So we have 2 points, x1, y1, x2, y2, and the average rate of change is just the slope, which would be 2 minus 6 over 5 minus 0, negative 4/5. So the average rate of change, since it's negative, means we're decreasing, and it's actually the slope of that dotted line. That's called a secant line. So the average rate of change is the slope of the secant line. We can also find the average rate of change if we're just given the function and some values for x. So the way your textbook lists your x values would be like what they've done with the t equals -1 and t equals 4. Those would actually be your x1 and your x2. So we need a y1 and a y2. y1 will be the function when we plug x1 in for all of the t's. So -1 squared plus 2 times -1. So 1 minus 2, that would be -1. And then y2 will be the outcome when you plug x2 in. So h of 4 would be 4 squared plus 2 times 4. 16 plus 8 is 24. Now we can use the slope formula, and that would be 24 minus a minus 1 is plus 1 over 4. Again, minus a minus 1 is plus 1. 25 over 5, which is 5. So that's the average rate of change. This one's a little more difficult because we're plugging in letters, not just numbers. And the first x that's given to us, we'll call that x1. The second x, x2. y1 will be the function with x1 plugged in. 4 minus 2 squared would be 0. And then we're going to plug in x2 to find y2, 2 plus h. So everywhere we see an x, we write 2 plus h. 4 minus 2 plus h squared. Now remember, a big common mistake is to just take the squared, square the 2, and square the h. But that's not how that works. We are having to write 2 plus h twice and FOIL it. I have a subtract and then a bunch of stuff. Whenever I have that, I seal off what's to the right of the subtraction with some kind of bracket or parentheses to help me remember that the subtraction is going to affect everything to the right of the minus, and it will distribute. So sealing all that off will help remind me of that. When I FOIL, then I would have 4, and then 2h plus 2h would be 4h, and h squared. Now, the minus in front distributes, so it's 4 minus 4h minus h squared. And when I combine like terms, I end up with negative 4h minus h squared. So all of that is y2. Now I'm ready to do the slope formula. So let me scoot this up a little bit. M equals y2, which I just found is negative 4h minus h squared, minus y1, which was 0, over x2, which was 2 plus h, minus x1, which was 2. So that gives me negative 4h minus h squared. On the bottom, the 2's would cancel, and I just have h. And then there are h's in common in all three terms. If every term that you have divides by something, you can go ahead and divide it out. I couldn't do it if it was just 2 of the 3. So when I divide out the h's, I'm left with negative 4 minus h. And so that's the average rate of change. Now the instructions say a linear function is given. Find the average rate of change between x equals a and x equals a plus h. Show that the average rate of change is the same as the slope of the line. This is a very calculus-y problem. They're trying to lay a little bit of foundation here for calculus. So x equals a, that would be x1, and then x2 is a plus h. y1 is x1 plugged in. So f of a would be 1/2 a plus 3. y2 is a plus h plugged in. So that would be 1/2 times a plus h plus 3. And let's go ahead and distribute the 1/2. 1/2 a plus 1/2 h plus 3. Now the slope formula, which is the average rate of change. y2, 1/2 a plus 1/2 h plus 3 minus y1. Again, I'm going to seal up in parentheses because I'm subtracting more than one term, and I don't want to mess up my signs. y1 is 1/2 a plus 3 all over x2 minus x1. Let's distribute the negative. So on top I have 1/2 a plus 1/2 h plus 3 minus 1/2 a minus 3. The bottom is a plus h minus a. Now let's combine like terms. On the top, my 1/2 a's are gone, my 3's are gone, and all I have left is 1/2 h. On the bottom, my a's are gone, I just have an h, and then I can cancel out my h over h, and I'm just left with 1/2. So all of this that we just did was part A of what they asked. That is the average rate of change, 1/2. Part B says show that the average rate of change is the same as the slope of the line. So my line is 1/2 x plus 3, and it's in slope-intercept form, mx plus b. So the slope is always the number in front of the x, which is also 1/2, so they are the same.